This lesson is all about radicals, but before we start radicals, we do need to talk about perfect squares. The perfect squares are numbers that you can take the square root of easily, as in it does not give you a decimal, it gives you an integer answer. We should know our perfect squares up to 20 squared. So this is our list of our perfect squares up to 20 squared, right? Because 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So 1, 4, 9, 16, 25, and all of these numbers are considered perfect squares because they were formed by something being squared. To simplify a radical, we're going to rewrite it as the product of a perfect square and another number. And then we're going to take the square root of just the perfect square part, leaving the other number still under the radical. This is how we can reduce radicals without getting decimal answers. So for 162, I would look at my list of perfect squares, and I usually start below 162, so anything less than 162, and I'm going to check, does 144 go into 162 evenly? Does 121 go into 162 evenly? And I'm going to keep working my way backwards because I want the biggest possible number to be in my product. And 81 goes into 162 evenly. So I'm going to rewrite 162 as the square root of 81 times, and if I divide 162 by 81, I get 2. So 162 is really 81 times 2. I could take the square root of 81 to get 9, but I can't take the square root of 2, so that stays. And that's my answer. For B, for 147, so I would go to my list of perfect squares, anything below 147. And I'm going to keep checking which ones go in evenly, which one goes in evenly. And I finally, once I hit 49, 147 divided by 49 is 3. So that's 49 times 3. The square root of 49 is 7, but we can't take the square root of 3, so it stays under the square root. One of the biggest things we have to remember is that once you take the square root of a number, the square root symbol is gone. It's no longer under the radical. It only stays under a radical if you were not able to take the square root of it, like the 3. So here's one for you to try. You can pause and check your answer on Google Classroom. Two radicals can also be multiplied by each other. We would just multiply the like parts. So if there was a number in front and a number under the square root, you would only multiply numbers out front. You would only multiply numbers under the square root. So for example, 2a, we have 9 root 2 times root 2. So I can multiply just the radical parts. The 9 didn't have anything in common to multiply it with, but the 2 root 2's, 2 times 2 is 4. The square root of 4 is 2, because 4 was a perfect square. So this is really 9 times a regular old 2, so my answer is 18. This is always going to happen if you have a radical times itself. Essentially, the radical symbol is going to cancel out, and you're just left with that number. So if we use that same here, 28 root 3 times root 3, the root 3 times root 3 is really 3. So this is just going to be 28 times 3, which is 84. So here's one for you to try. You can pause. Answers posted on Google Classroom. The last thing we need to do with radicals is rationalize a denominator. We're not allowed to leave a radical in the denominator. To get rid of it, we would multiply both the numerator and denominator by that denominator number. But there is a shortcut. We don't have to show the step of doing the multiplication on the top and the bottom. So for our first example, 3, we had 24 divided by the square root of 2. We know we're not allowed to have the square root of 2 in the denominator. So I could multiply both the numerator and denominator by that square root of 2. Down here, just like in our multiplication problems, root 2 times root 2 would just be 2. 24 times root 2, those are not like terms, so it stays 24 root 2. And now I will reduce. 24 divided by 2, these are like terms, neither one's in a radical. I can touch those, 12 root 2. The shortcut is we know that this number here is going to have to end up in the top because it's going to be multiplied by the top. And we know this number down here is going to lose its radical because it's going to get multiplied by itself. So the way I view these problems is I do 21 divided by regular 3, which is 7, and then I move the square root to the top to get my answer. So instead of showing the steps of these two, I've kind of done it in my head. I divided 21 by 3 to get 7, brought the root 3 to the top. It went with the 7 now. So in C, if I wanted to do that, I would be moving the root 5 to the top, and I would be doing 19 divided by 5. So I could leave that as 19 over 5 if it doesn't go in evenly, or I could actually divide 19.5 and get a decimal. That's the only decimal that would be allowed. 3.8 root, oh, shouldn't have said 15 there, it should be 5. I prefer to see my answer like this, but this is still perfectly acceptable. So here's the last one for you to try. Pause or end the video. Answers are posted on Google Classroom. And that is everything we need to know about radicals.